Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Excuse me. Today's very easy puzzle is called Element Sudoku Magnesium by Zinker. And we have the MG to signify the magnesium symbol. Though the G should be a lowercase one, but anyways. We have... Where are the rules? Normal Sudoku rules apply, which means in each row, each column, and each bold outline 3x3 box, the digits 1 through 9 must appear exactly once. Additionally, we have green spectral lines, where adjacent digits along green spectral lines differ by at least 5. So, for example, if this were, say, a 3 here, this would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. We also have a blue spectral line, where the digits on the blue spectral line sum to the atomic number of magnesium in the periodic table of elements, which is 12. We have so that means these 4 digits must add up to 12, because the digits on the spectral line must add up to 12, which is the periodic number for magnesium. We have yellow atoms, where around a yellow atom, all surrounding cells are either all even or all odd. And all atoms are given. So that means there is a negative constraint, which means there is, so either all of these digits are all even or all of them are all odd. And if they're not, if there is a 2x2 area that has all evens and all odds in them, they must have these yellow atoms between those 4 cells, which are all the same parity. Finally, we have electrons, where cells connected by a white electron contain consecutive digits, and cells connected by a black electron have a 1:2 ratio. And in this case, not all white and black electrons are given. So, for example, if this were, say, a 4, this digit would have to be 2 or 8 to be in a 1:2 ratio with it, and this would have to be 3 or 5 to be consecutive with that digit. So, those are examples of, and we have, I think, 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 electrons, which means that this is a electrically neutral magnesium representation. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. These 4 cells. So, let's look at the cells that are in a 1:2 ratio with multiple cells. The only digits that can be in a 1:2 ratio with two unique digits. Multiple cells doesn't matter necessarily if these were different boxes. But since this is the same box, these must be unique digits. So the only digits which can be in a 1:2 ratio with 2 unique digits are 2 with 1 and 4 with 2 and 8. So this has to be 2 or 4 here to be in a 1:2 ratio with 2 unique digits. As must this, that's in a 1:2 ratio with 2 unique digits, and this is in a 1:2 ratio with 2 unique digits. Well, couple of things that we know from that then. On the green spectral line, which otherwise I call a whisper 5 line, you'll always alternate between low digits and high digits on a whisper 5 line. Because if you have a low digit, what digits can be next to it? And the low digits are 1 through 4, and the high digits are 6 through 9. Well, 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can be next to only 9. So next to a low digit must be a high digit. And what digits can be next to a high digit on a whisper 5 line, or this green spectral line? Well, 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1 through 3, 9 can be next to 1 through 4, all of which are low digits. So next to a high digit must always be a low digit. So that's why you know that you will always alternate between low and high digits on a whisper 5 line, or these green spectral lines. Well, this is guaranteed to be 2 or 4, which is a low digit, which must be next to high digits, and those high digits must be next to low digits, which must be next to high digits on the whisper 5 line, which must be next to low digits. These are then high, and then this must be low. So this is now a low digit. The only two digits that can be next to 2 and 4 besides 2 and 4 are 1 and 8, right? 2 can be next to 1 and 4 as a pair, and 4 can be next to 2 and 8 in a 1 and 2 ratio. Well, since this is high and this is low, this has to be 1, and this has to be 8. 1 is in a 1 to 2 ratio with 2, which is in a 1 to 2 ratio with 4. That makes that 8 there. 2 and 4 obviously low digits. 2 and 4 can be in a 1 to 2 ratio with 1, 2, 4, or 8. And these 4 digits are the same parity. Well, if we tried to make them even, we'd have 5 even digits in this box, which is not allowed. Therefore, these must be odd parity, which we'll mark as pink, I guess. This is now consecutive with another digit, so this cannot be pink. It has to be the other parity, which is even. So this must be 2, 4, or 8 there. That means these 4 digits have to all be odd also. We'll mark that as pink. This is a high digit, which is in a 1 to 2 ratio with another digit, so it can only be 6 or 8 here, because 5, 7, and 9 cannot be next to a black Kropke dot, because if you have 5, 7, and 9, you get 2.5, 3.5, 4.5. If you double 5, 7, or 9, you get 10, 14, or 18, none of which are digits. So if this is 6 or 8, this would have to be 3 or 4. To be consecutive with 3 or 4, it's 2, 3, 4, or 5. To be consecutive with 2, 3, 4, 5, it's 1 through 6 here as possibilities. So those are what we have there. These two digits are in a 1 to 2 ratio, and since we know that you alternate sets on a whisper 5 line, this must be a different set than that, and this must be a different set than that. But since these are different sets and these are different sets, these must be the same set. Well, you can never have two high digits in a 1 to 2 ratio with each other, right? Double 6, you get 12. Double 7, you get 14, etc., etc. So these both have to be low digits, which means the next digits next to them must be high. The digits next to this also must be high. The digits next to those must be low. The digits next to those must be high. That makes this low, which makes that high. And this is in a 1 to 2 ratio. So it's either 1, 2 or 2, 4. But this digit is next to 2 unique digits on a whisper 5 line. This digit is next to 2 unique digits on a whisper 5 line, which means none of them can be 4, because 4 can only be next to 1 unique digit on a whisper 5 line. So this must be a 1-2 pair here. Okay. This is 3 and 4 is also low. So this is low here. We have 4 lows guaranteed. in row 4, which eliminates lows in the rest of the row, so they must be high or 5. Let's make this then yellow instead of pink. I usually signify 5s as pinks. And this must be high or 5. Okay. Well, where then is the last low in this right central box? It has to be here. That must be a 3. So the remaining lows in row 6 must be 1 and 2, and therefore the rest of the digits in row 6 have to be high or 5. Same with the central box. This digit is next to 2 unique digits on a whisper 5 line. So this cannot be 4, because 4 can only be next to 1 unique digit on a whisper 5 line. And it can't be 1 or 2 because of the 1-2 pair in the box. So this cannot be 4, it's 3, which means this can't be 3. That's 4, which is in a 1-to-2 ratio with 8. 4 eliminates 4 in the rest of the column. This is 2 and 8, then, which has to be in a 1-to-2 ratio only with 4. So this is 4 there. And this can't be in a 1-to-2 ratio with 8 because of 8 in the column, so this must be 2. So this is 2, which makes this 8. These are even. This is also low. So we have all the low digits accounted for in column 6. Also, the central box. So this is high or 5. And one of these is guaranteed to be 5, because 5 can never appear on a whisper 5 line. Because if you have 5 on a whisper 5 line, and you subtract 5 or more, you get 0 or less. And if you add 5 or more to 5, you get 10 or more, none of which are normal Sudoku digits. So since 5 has to be here, this can no longer be 5. It's consecutive with 4. That makes this, therefore, 3, which makes that a 2 to be consecutive with those digits. So these are both low. 4 must be next to 9 on a whisper 5 line. So these are both 9. 8 is a high digit, which means the remaining high digits in row 7 have to be 6 and 7 as a pair. That eliminates high digits in the rest of row 7, so these must be low or 5. This has to be 3, which can only be next to 8 and 9 on a whisper 5 line. So this is 8 and 9. This digit is next to 2 unique digits on a whisper 5 line, so cannot be 6, which makes that 7 because we don't have 8 and 9 available. That leaves this as a 5-6 pair here in the central box. Where is 5 in this right central box? It has to be one of these 3 digits because these are both high because they're on a whisper 5 line. Therefore, this can't be 5 here. It's a high digit. This digit is next to both 1 and 2 on a whisper 5 line, and it cannot be 7 because of 7 in the column. So 6 is not available. That can only be next to 1 unique digit on a whisper 5 line. So this must be 8, 9 as a pair. That means this can't be 8 or 9 as a pair because of the pair in the row, and it's next to 2 unique digits on a whisper 5 line, which means it can't be 6 because 6 can only be next to 1 unique digit on a whisper 5 line. So this must be 7 here. Now this digit cannot be 7, 8, or 9 because of 7 and 9 in the column and 8 in the box, so that leaves that as 6. 6 eliminates 6 here, so it's 5 and 6. So this is not high, it's 5. This is not 5. And the remaining digits in row 5 have to be 4, 8, and 9 available. Okay. Remaining digits in this right central box are 5, 7, and 9. This can't be 7 or 9 because of 7 or 9 in the column, so this must be a 5. That eliminates 5 in the rest of the box. So this is 7, 9 as a pair. That leaves the remaining digit, a tie, in row 4 as a 6. And then this must be a 5, 7 pair here, remaining in row 6. This has to be a low digit. The rest of column 6 have to be high or 5. These are all odd digits. Remaining, and this digit is consecutive with 8, so this is 7 or 9. We have 179 here and 179 remaining in column 5. This digit is next, cannot be 1 or 4, so this has to be 2 or 3. These have to be a 1-2 pair remaining, and to be next to the 7 on the Whisper 5 line. And 2 eliminates 2 here, so that's 1, which makes that 2. 1 eliminates 1 in the rest of the box, so this is 7 and 9 as a pair in column 5. That eliminates 7 and 9 in the rest of the column. So no 7 or 9 here, it's 1. Also means remaining digits in row 3 have to be 4, 5, and 6. So no 4 available here because of 4 in the column. No 6 available here because of 6 in the column. Let's see. These are in a 1-to-2 ratio, and it cannot contain 2. So this is either 3, 6, or 4, 8, because we don't have 1, 2, or 2, 4 available. This can't be 4, which means this can't be 8 there. 2 eliminates 2 here, so that's 3. Remaining digits of row 7 are 1, 2, and 5. And for 4 digits to add up to 12, it's going to have to be either 1, 2, 3, 6 or 1, 2, 4, 5 on the line. That means 1 and 2 have to be on this line, which means this can't be 1 or 2. It has to be 5. That eliminates 5 in the rest of the row. And as I said, okay, this can't be 2 because of 2 in the column, so this must be 1. Which means this can't be 1 or 5, it's 2. Again, to add up to 12, it's either 1, 2, 3, 6, or 1, 2, 4, 5. And since it can't contain a 5, it must be 1, 3, and 6 here. That eliminates 1, 3, and 6 in the rest. And this has to be odd, so there's no 6 there. This 1, 3, 6 triplet eliminates 1, 3, 6 in the rest of the box. So this can't be 6, this is 7. That means this can't be 7, it's 6. 3 can't be here because of 3 in the column. Remaining digits of this lower left-hand box are 4, 8, and 9. 6 cannot be next to 2 on a Whisper 5 line, so this is 1, which makes that 2. 1 eliminates 1 here, so that's 2, which makes that 1. 5 eliminates 5 here, so this can't be 5. It's 7, that means this can't be high, it's 5. 5 eliminates 5 here and here, whereas the 5, that leaves this as a 4. This can't be 4 or 5, it's 6, which makes this a 5 there. 4 eliminates 4 here, so where's 4 in this left central box? It must be here. 3 eliminates 3 here, so this can't be 6, because if this were 6, 3 would have to be there to be in a 1-to-2 ratio. 1 eliminates 1 here, so that's 3. No more 3 available here. 4, this 8, 9 pair eliminates 8, 9 in the rest of the column, so no 8 or 9 there. It's 4, that eliminates 4 in the rest of the box. 6 eliminates 6 here, so that's 1, which makes this 6. This is odd, so it cannot be 8. It must be 9, which makes that 8. 8 eliminates 8 here, so it's 9 and 8, which eliminates 8 there, so it's 9. 9 eliminates 9 there, so that's 8. Okay, so we know all the rest of these are odd, so that's fine. These 4 digits have to be the same parity, and we have 2 even digits here. So if we had all of these be even, that would be 6 even digits in a box, which is not possible. So these must be odd, and then are 1, 3, 5, and 7. So this must be 3, 7 as a pair in column 1, and we have 1, 5 as a pair in column 2. That leaves us 2 and 8 remaining in column 3. And 2 and 8 isn't only in a 1 to 2 ratio with 1 or 4, but this can't be 1 because of 1 in the column. So this must be 4 there. 2 eliminates 2 here, so that's 8 and 2. 8 eliminates 8 here, so that's 3, which is in 1 to 2 ratio with 6. Okay, 3 eliminates 3 in the rest of the row, so that's 7 and 3. That's 3 in the corner. We celebrate because we're close to solving this. 1, we don't have enough information. 2, we have 8 twos in the grid, so we know where the last 2 is. It's there. 3, we have 8 threes in the grid. We know where the last 3 has to be. It has to be there. 4, in row 2, 4 cannot be here because of 4 is in the boxes, and these are filled, so 4 has to be there. That gives us 8 fours, so we know where the last 4 has to be. It has to be there. 5. We don't have enough information about 5s. 6s. 6s in row 1 cannot be here or here because of 6 in the boxes. Can't be here because of 6 in the column. So it must be here, which means this is not a 5. That's a 6. That gives us 8 6s. We know where the last 6 has to be. It has to be there. 7s. We don't have enough information about... Actually, we do. We have some information. In row 1, 7 can't be here or here because of 7s in the boxes. So 7 has to be there, which makes that not 7, so that's 9. 7 in column 6, then. Cannot be here because of 7s in the boxes, and these are filled out, so it must be here. So this can't be 5, which means this can't be high. That's 5 there. That leaves this as 7. This is 5. 5 eliminates 5 here, so it's 1 and 5. 7 in row 8 cannot be here because of 7 in the boxes. Can't be here because of 7 in the column, so 7 has to be there, which means this can't be 7. That's 9, which makes that 7. That should be all 9 7s. 8s. In row 8, 8 cannot be here because of 8 in the box, so 8 must be there. We have 8 8s now. We know where the last 8 has to be. It has to be there. 9. In column 8, 9 cannot be here because of 9's in the boxes, and they're filled out there, so this must be 9 there. And 9, we have 8 9s now remaining in the grid, so the last 9 is there. That means we have 1s remaining. 1 has to be there. And we have 5 remaining. So 5 has to be here and here. And that's a solution. Yep, fairly straightforward. It's pretty interesting how these interacted too. But not too difficult to solve for these clues. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.